A successful deep draw is determined by a variety of variables, which impact metal flow. The first step is to determine the size of the laser cut blank, a critical step for a successful draw. The amount of material needed to form the final shape must be included within the laser cut blank. Because the draw process causes thinning and thickening of the metals, this step is extremely important to achieve the desired final shape. Another critical step in the deep draw process is adding polishes to the die surface and applying lubricants to the die surface and blanks. Lubrication assists with friction and galling and ensures the highest quality part is formed, while protecting the deep draw tooling. Galling occurs when two metallic surfaces slide against each other, creating friction. This can harm the product and the tooling. Avoiding galling allows the free flow of metals, helping the blank to slide easier. The draw entry radius, or DER, controls how easily material flows into the die cavity. If the radius is too small, material flow is restricted, increasing stress and causing thinning or fractures. If the radius is too large, the material can lose support and wrinkle as it enters the die. A properly designed die entry radius allows smooth, controlled material flow while maintaining part quality. The punch nose radius, or PNR, is equally important because it can impact how much stretching of the sheet material is taking place. A larger punch radius can reduce localized thinning and strain, lowering the chances of material fracture. A PNR that is too large will decrease control of the material, and puckering or severe stretching may occur. The draw ratio is the relationship between the blank diameter and the punch diameter, determining how much the material is formed in a single operation. During drawing, the material flows inward under compression while the walls of the part experience tension. If the draw ratio is too high, the material can exceed its forming limits and tear. The correct draw ratio allows the material to flow evenly, maintaining consistent wall thickness and producing a strong, uniform component. Every successful deep draw starts long before the press cycle begins. By carefully controlling the variables that affect metal flow, manufacturers can produce stronger, more consistent parts while extending tooling life and reducing scrap. Whether you're designing a new component or optimizing an existing process, understanding these fundamentals will help you achieve better results with every draw. If you're looking for a trusted manufacturing partner for your next deep drawing project, visit ToledoMetalSpinning.com/contact